In this video, we're going to continue our study of functions and function operations and talk about inverse functions. So inverse functions are functions that are symmetrical about y equals x. So if you graphed them and you had a function that went like this, we'll say, that's just a line. There is this imaginary line of y equals x, so that's a diagonal line through the coordinate plane. The inverse of that pink line would actually be a mirror image of the across the dotted line. So it would look sort of like, but better. It would look sort of like that. So if you folded the coordinate plane across that blue dotted line, you should see that the pink line and the green line line up to each other. So they are inverses. Inverse is symmetrical about the line y equals x. The other thing that so what that basically means, though, is that for inverses, they flip-flop their x and y coordinates. So if the pink function has f of 2 equals 1, and we'll call this f of x, and we'll call this one g of x, then the g function has f of 1 equals 2. So the coordinates here would be 2, 1, and the coordinates here would be 1, 2. And because the coordinates of G are the coordinates of F, but the x and y's are flipped, this is what's called an inverse. And when you write it in function notation, you would write F with a little -1 up top, and then x, like that. So this -1, it's not an exponent. It's a symbol that tells you it's the inverse of the function. It's a reciprocal function also. So for example, if we want to find an inverse, we take the function, and instead of having f of x, we would write y instead. So we're going to rewrite with y equals instead of f of x. Then we are going to switch y and x. And then we are going to solve for y. So for example, if I have the function f of x equals x plus 4, the first thing I'm going to do is I'm going to rewrite with y instead of x. So y equals x plus 4. Then I'm going to switch the x's and the y's. So now I have x equals y plus 4. So notice I switched the x's and the y's, and now I'm going to solve for y. And the way I do that is I'm just going to, in this case, I'm going to subtract 4 to the other side, and then I'll rewrite it, y equals x minus 4. So this is the inverse of this here. So in fact, we would write it as f of -1, x equals x minus 4. So this should be our final answer, because that's the inverse. All right? Say we had f of x equals x to the 7th. And I want to write the inverse of that. So again, I'm going to start by writing y equals x to the 7th. Then I'm going to flip-flop the x and the y. So I have x equals y to the 7th. And now I need to isolate y. So how do you undo raising something to the 7th power? Well, how did you undo squaring something? You square rooted it. How did you undo cubing? You cube rooted it. So we're going to 7th root it, which means that we have the root symbol, but with a little 7 out here in the index, and we would end up getting y equals the 7th root of x, and then we would rewrite it with the correct notation, f negative 1 of x equals the 7th root of x, and that would be the inverse. All right. What about this one? If I had f of x equals negative 3x plus 1, go ahead and pause the video and see if you can do it yourself. Okay, if you did it yourself, you rewrote the equation with y instead of function notation. You flip-flopped the x's and the y's, and then you did opposite operations until you isolated y, and then you rewrote it with the function notation at the end. So that is how you would find function notation. The next thing that you might, how you would find the inverse. The next thing you might need to do is to determine if two things are inverses. And if they are, to prove functions are inverses, we're going to use composition. So what we learned in the last lesson. So in that case, if f of g of x equals x and g of f of x equals x, then f and g are inverses. And you could say g is the inverse of f of x. Cool. All right, so here is the directions. Show that f of x equals 4x plus 2 and that the inverse of f of x equals 1/4 x minus 1/2. So in order to do this, we're going to use function composition. So we're going to show that f of the inverse of x is equal to x. So we're going to do that by plugging this value into the x of the function. So we would have 4 and then 1/4 x minus 1/2 plus 2. If we distribute the 4, we get x minus 2 plus 2. Well, x minus 2 plus 2 is just x. Yay. All right. And now we're going to show it the other way. So f of negative 1, f of x. So we're going to go backward, or not backwards, it's the other operations. So this will now be plugged in here. So we have 1/4 4x minus 2 minus 1/2. Distribute the 1/4 and you get x minus 1, oops, sorry, that's plus. X plus 1/2 minus 1/2, which is just x. Check. So those two functions are inverses. Okay, one final thing that you have to know about inverses is not all functions actually have inverses on the whole domain. So think for a second back to a quadratic. If we have this quadratic, its domain is all real numbers because for any x that we plug in, we will get a y value out of it. However, if we put our y equals x line here, and we ask for the inverse of this parabola, what happens is we end up getting something that looks like this. And this pink function won't pass the vertical line test. So we would actually have to limit the domain of this function, or it's just not a function at all. So there is an inverse, it's just not an inverse function because this doesn't pass our vertical line test. All right, so you'll use your CAS in order to figure some of those things out. Okay, thanks.